Hello everyone, welcome back to the YouTube channel. I'm so sorry that I took a brief pause making the video because I was a bit of a discouraged when I got rejected from my education major, which is my dream major, and now just trying to apply from transfer school. So I hope I can get into the major that I desire for this fall, and now I can start my new chapter at another university. I'm so sorry that I will be leaving the UW from this after the spring quarter. I will miss UW so much because it's just I know you guys are amazing. I make some amazing friend. I miss my friend, miss my classmate, I miss all my teachers and professors that I met. And I also love the campus. No matter where I end up going in the fall, I love you all. You guys gave me the motivation to become like effective and an awesome educator. And always remember, I love you. I love every one of you. You guys are amazing, and you guys made my part of my UW college life. And I will never forget all the 3 quarters at University of Washington do math tutor on Discord. I will never forget this memory in my life. Now this is gonna be section 14.7, which is like the toughest part of a partial derivative in Math 126. Partial derivative, and now we just have some like the application. And we learn in Math 124 to find the maximum minimum, and now we try to apply to like for multivariable calculus. So let's get started for question number 3. Find the local and the max and the minimum values of saddle point. We have f x y equal to this function 3 minus x to the 4 plus 2x to the squared minus y squared. Your first step is use the second partial derivative test. It's capitalized D. So if capitalized D it is positive, while fxx a and b it is positive, there's local minimum. If capitalized D it is positive, while the fxx a and b is negative, then local maximum occurs. If the capitalized D is a negative, then there's no minimum, there's neither local minimum or local maximum. We had a multivariate function is fx x comma y equals to 3 minus x to the 4 plus 2x squared and then minus y. For fx and xy, it's gonna be like a negative 4x x to the cubic plus 4x. Then xy gonna be negative 2y because it's only y variable. For fx and s, then it's the same rule as the partial derivative, where if you're trying to find the partial derivative of x, treat y as the constant, x as the variable. If you find the partial derivative of y, then the y is the variable, x is the constant. Now finally gonna be fyx equal to 0. fxy is also 0. But fxxy gonna be negative 12x to the square plus 4. Then fyy is gonna be negative 2. Now we just set all like fxx and fyy, or set as like fx of xy, fy, xy, set both of them equal to a 0, set up like a linear function. And to find the point. You may gonna find is equal to a 0 or like a negative 1 and positive 1. Those are the critical point. Critical point occurs when the first derivative, partial derivative is 0. And then you plug those like the critical point, then find local maximum and local minimum. If the k plus d is negative, then this is a saddle point. Now you can just define the point based on your critical point, your like k plus d to determine where is local maximum, where like a local minimum. It's the same thing. In this case, we're going to be like a 27x to the negative 1, 27 to the y power to the negative 1. It's the same procedure as problem number 2, which you find each of a partial derivative, the first partial derivative. And then you maybe just find like the second partial derivative and like the critical point. The same procedure. Same as this. If you want to take fx, y, their variables. If you want to do fy, x, their variables. Same as fxx, just the same thing, just based off of x, fx, then fxs, just the derivative, take the x variable again. So if you find the fx or xx, ignore the y variable on the y terms because they're not what you need to take the derivative of. It's the same thing for number 5. We just need to find the first partial derivative for x and y, the second partial derivative of x and y, and then the critical point. Then use the second partial derivative test to test like each local point. No, the each critical point, not local point. Local point is dining hall at University of Washington Lender Hall. If you're as soon as you UW, then that's your place to eat. Absolute maximum and minimum. Those are gonna be the different concept that you will encounter in chapter 4.7. So the first step is like find the absolute maximum and minimum. You recall what you learned in Math 124, which in section 4.3, use the second, no, use the first derivative. Actually, this is like section 4.1. Absolute maximum and the minimum is like in a closed fixed interval method. We have functions f of x, an interval of a and b. You find the critical point, find local max, find like absolute maximum and absolute minimum. Now, which is the same thing as chapter 14.7, which is like multivariate functions. And we just find the f of like fx, xy, and fy, xy. And we find this like the first partial derivative. And then set them equal to 0 to find like the critical point. Then just to find those absolute minimum and maximum. So for x absolute value equal to 0, 1, so it means like x and y, they're from negative 1 to 1. Inclusive. So including your region is gonna be negative 1, 0, and 1. Those are your region. Because notice how like absolute value. So why the f can be negative? So your shape is gonna be a square with each side length of 2. This is the same thing. X equal to 0 and 0. This means like gonna be x y. The upper bound gonna be a square root of 3. That is your upper bound because like, and that's just like this circle, like to have a radius of like square root of 3. It's the same thing as number 6. You just have to find a region. In this case, like x and y, they are from the negative 1 to 1. They're the circle. Number 6 actually zero. Number 7, they're just like gonna be like a negative, but just have to like a restriction here. So it cannot be negative. So it's not gonna be like a negative square root of 3 and a positive square root of 3. It's only positive because there's like have restriction for every single variables here. Okay, number 9, it's gonna be like a harder one. So, but I'm gonna introduce those. The distance formula in this case, you have x, y, and z equal to 4. So you choose like equations like gonna be the distance on a given point. The shortest distance is gonna be the absolute value of a l plus b m plus c n minus d. Perhaps l m n is the point. The shortest distance from ax plus by plus c d equals cz equal to d. In this case, it's gonna be like ABC, they're 1, and D is a 4, and then it's gonna be LMN gonna be 1, 0, and then negative 4. It's gonna be the shortest is gonna be absolute value of AL plus BM plus C minus D over the square root of A squared plus C squared minus B squared. That is your distance, and you just plug into the equation just to find the D. That is your answer, what you want to find. Number 10 is more of a complicated, but it is solvable. Don't be afraid. Every problem can be solved with a specific method. Don't be afraid. Never be afraid of a question. Because what will kill you is your fear, and no fear of a weed out. If you're no fear, you're not going to be weeded out. Trust me. Have this like z squared plus x squared plus y squared give me closer point for 4, 2, and 0. Do you know that this is formula learning 12.6 or chapter 12? That D is going to be x minus, perhaps you have a point x, y, z, and the 4, 2, 0. This formula is going to be the square root of x minus 4 squared plus y minus 2 squared plus x squared plus y squared. Because z minus 0 squared is z squared. And z squared equal to x squared plus y squared. And they have x and y like a partial derivative. It can be wrote as x minus 4 squared plus y minus 2 squared plus x squared plus y squared. And then find like the and then what you need to do is find like a minimum value using like the second partial derivative test. So what you do is find the critical point and then test each like critical point. That's your process. Okay, those are the questions. I will set like a put them into final exam review, but like this is all for section 14.7 homework videos. And I hope this video found helpful because I just still recovering from the major rejection and my transfer process. Thank you everyone for the understanding, and I hope you found helpful and have a wonderful day. This is gonna be May the 4th. Remember, first it's gonna be in week 6. We can make it. We will do well in the spring quarter. Just stay strong. I'm always here with you. I love everyone for you all. Thank you and have a great night.